Hello everyone, my name is Saurabh Singh and today I'm going to teach about the lime, which is very important topic of a modern concrete technology. After watching this video, if you have any doubt, you can call on my this number and you can also write a email on saurabh.singh@mygyanbihar.com. So come on the learning objective and learning outcome. Here you will know about the uh, lime and you will understand different behavior of lime. You will also know in learning outcome you will able to learn about the lime uses, how we use lime in the cement and what is the role of lime in the cement. And you will be also able to know about the different types of lime. So come on the introduction. Lime. In introduction, first we will see the definition of lime. Definition is the very important things whenever you are doing. Suppose you are doing the study of anything, you should be know what is the basic definition of that thing. So lime is an important cementing material used in engineering construction. A cementing material may be defined as the material which has capacity of holding a structural unit together with the sufficient strength. Among these group are include lime, natural cement, gypsum, Portland cement, as well as various other synthetic products. Now you can see this is the photograph of a lime which we used, which we take in the construction of a cement. And in old time, lime was using as a binding material, and you can also say, and you can say, cement is the artificial alternate of a lime. In old time, we are using lime surki as a binding material, as a mortar in the construction of many structure. If you will see the old structure, there are many structure which is made up of lime as a binding material. So, cementing material, the material which has a capacity of holding structural unit like bricks, stone, aggregate. This is the examples of some cementing material which is given here: lime, natural cement, gypsum, Portland cement. Lime, if you will see the chemical name of a lime, it is a calcium which is represented by CaO. Okay. And what is the use of lime? Ordinary building in massive momentous and places forts as a reliable and economical cementing material. Now you can see here uh, lime is using lime is used here as a binding material and lime as a reliable and economical cementing material. If you will see the cost of lime, it is very less in the comparison of cement. So you can also say it is very economical cementing material. Now we will see the classification of lime. And lime is available in the market in three main types, which are quick lime, hydrate lime, and hydraulic lime. And this is the second one is the classification based on composition: quick lime, hydrate lime, and hydraulic lime. As you can see, this is the image of this is also image of quick lime. This is the image of hydraulic hydrated lime, and this is your hydraulic lime, which we take in the use of construction of a cement and preparation of a cement. Now we will see the lime cycle of the lime, how it became lime. First, as you can see, this is your calcium carbonate, which is represented by CaCO3, and calcination and burning plea, we got the quick lime, plus atmosphere. CO2 will go in the atmosphere, and when it will be added with the H2O, what will happen? CaO2, uh, it will become the hydrated lime, and it will be cementing properties. It will be also a cementing material, CO3 plus H2O. Now we will see the quick lime also called fat lime, and we also called it rich lime and pure lime. In it, CaO is greater than 93% by weight, remaining being MgO and very little clay. Quicklime is an atmosphere amorphous and shapeless white material. It has very highly affinity for the water and carbon dioxide. It will absorb the moisture quickly from the atmosphere and converting itself into the carbonate of calcium. Like as you can see here, that is it, your chemical formula. CO plus CO2 will become CO3, and if CaO plus H2O, it will become CaOH2. Okay. Come on the manufacturing of a fat lime. This is also a very important point in the lime. The essential raw material for the manufacturing of a quick lime is a rock is called limestone, which is known as CaCO3. Limestone is a sedimentary rock which occur in the nature in the good evidence forming hill range, and this is used for the construction of buildings, and it is also used for the manufacturing of a cement. Now we will see the quicklime here. Quicklime is a caustic white alkali with the name with the chemical name calcium oxide. As you can see, that is your it can be also we can also call it a calcium oxide. Uh, Quicklime can be also named as calcium oxide. As you can see here, that is your limestone plus quicklime. It will become carbon dioxide. As you can see, this is photograph of quicklime. And now we will see the hydraulic lime. It is that lime to which sufficient quantity of water has already been added at the manufacturing stage to the hydrate is completely means in hydraulic lime there is already presence of water in composition. uh, in composition it is CaOH2 in the structure. It is an powder form. It came in ready use for the compared to fat lime that has to be hydrated or slaked before the using. Means you can say hydraulic lime you can directly take in the use, and a normal lime you have to first put in the water, then it became the paste. It will be not like hydrated lime. Lime can be this lime can be also converted to hydrated form at the place of construction. This method is called slacking of lime. Now you can see this is the cycle, and this is your formation cycle of a calcium hydroxide, which is known as hydrated lime. As you can see, this is also image of your hydrated lime. Now we will come on the hydraulic lime. It is the different in the chemical composition form fat lime. In that it contains definite amount of clay in the addition to CO. Clay content in hydrate lime may be range from 10 to 30% by the weight. This clay plus lime composition give the hydraulic lime a property of hydraulicity. Now you can see this is the image of hydraulic lime, and which we take in the use of which we take in as the binding material, as you can see here. Now come hydraulicity, the capacity to set the hardened even under water and in the absence of air as between very thick wall. The hydraulic lime is the further classified into three subtypes on the basis of hydraulicity of the lime. There is also subdivision based on hydraulicity. First one is class A, B, C, and D. And as you can see here, there in class A there will be clay content 21 to 30% and set underwater in 24 hours. And B class is moderately hydraulic. Clay content will be here 11 to 20% set in water about a week. And feebly hydraulic, there will be a content of 5 to 10% set under the water within a month or more. Means it will take the more time. In class D, rich magnesium suitable only for finishing code do not possess hydraulicity. And now you can see here, and Can first we can see here can be used for the structural work and arches of dome. Means there is given in the table where you can use this kind of line like class A, where you can use the class A, where you can use class B, can be used for the construction masonry, and class C can be used for finishing coat in plastering, whitewashing, etc. Or you can also use for the masonry mortar with addition of pozzolanic material. Class D can be used for the finishing coat in plastering and whitewashing, and Class E produced by the burning lime noodles found soil like black cotton soil contains silica. It can be used for masonry mortar. Class F is also here. It is used generally for the undercoat and finishing coat of plaster. Now we will see the hydrolicity here. As you can see, this graph is showing the hydrolicity based on the clay content. As you can see here, now we will see the classification. Again, lime has also sometimes classified on the basis of raw material as stone lime, shell lime, and canker lime. Similarly, lime is distributed into the building lime, finished lime. The first type is required to possess good strength and ability to be mixed with the stone. It is used in the mortar that are used in the wall and the foundation. The finished lime, however, it is required to possess sufficient plasticity, good color, and quick setting property. As you can see here, this is varieties of lime. There is stone lime and magnesium lime, shell lime, and there is also clinker lime. And this is your image of stone lime, and magnesium lime is look like this. And clay lime will be look like this when it will be not in the form of the powder, and clinker lime will look like this. Now we will see the manufacturing process of a fat lime, and this is a common. Limestone has following constitutions. As you can see here, calcium carbonate it is between 60 to 65%. Magnesium carbonate it is between 5 to 30%. Clay content is 10 to 30%, and iron alkalis and sulfate are present in small proportion in many limestones. When their total content is less than 5% and the CaCO3, calcium carbon dioxide, is above 90%, the limestone is suitable for the flat lime manufacturing. But when present in excess amount, these slates make the lime unstable as a raw material. Besides, limestone sufficient quantity of fuel is also required to manufacture this lime. Now you can see this is the making process of a lime cycle. A lime, this is you can say this is also a cycle of preparation of a fat lime. Now we will see here calcination, which is the process of burning. Lime is manufactured by the process of burning or calcination of lime in suitable type of clay. The terms calcination significance heating the material at the red heat in the presence of air till the decomposes. Limestone disassociate with the heated at 880 degrees Celsius into the principal constituent. Calcium oxide and carbon dioxide as per above reaction, which is reversible. As you can see here, this is CaCO3 and it will become CaO plus CO2. It is essential that all the carbon dioxide produced burning the reaction is removed quickly from the clean, and this is dissociation temperature of reaction 880 degrees Celsius. It is not allowed to come down during the burning process. So this is the process of calcination where the chemical formula is also given here, and there is also atomic weight of each carbon, oxygen, and calcium is given here. CaCO3 will be divided into CaO plus CO2, and these are the calcination process of a quick lime. Now we will see the manufacturing process of a fat lime, how we manufacture a fat lime. The burning of limestone carried out either is clamp or clean. Clamp are temporary makeshift arrangement for the burning in an ordinary manner at the much lower cost. Kiln are, however, permanent structure built to carry out the burning operation at the regular intervals or continuous basis. Now you can see the image of clumps and clean where we have to manufacture the hydraulic lime. As you can see here, this is your fuel where you have to put the fuel. Like in fuel, in the form of fuel, you can use the woods, and rock gypsum is also here, and raw gypsum dust is also used for the preparation of this kind of lime. Now we will see the clam burning, how we do the clam burning for the preparation of a fat lime. It is a common method for obtaining small supplies of a quicklime. No permanent construction is needed. A small part of ground is cleared and fuel as a wood is staked in the alternate layer in the fuel as a layer. If coal is used as a fuel, it is mixed with the limestone instead of staking in the separate layer. The whole heap is covered with the mud plaster and small holes are left for the escape for the carbon dioxide. As you can see, that is your mud plaster, and this is image of flame burning. And F is, these are the fuels, and these are the rocks, and this is the gate of that flame burning. Now you will see how it works and what is the clamp burning. Clamp is ignite form of the base and allowed to keep on burning 2 or 3 days. Burning is discontinued when blues flame disappear at the top, and it allows to cool for 2 or 3 days. It is then dismantled. Limestone gets disintegrated into small pieces of small lumps of COO or lime. Such lumps are separated from the ash by the hand picking. Clam burning is a quick and cheap method of obtaining ordinary type of lime. It is not suitable for the large supplies of fat lime of good quality because burning is neither uniform or nor complete. Some stone may be overburnt and some may be underburnt, resulting in the wastage of raw material. There is considerable waste of heat generated by the burning fuel. Some of these came from the frequent cracking and plaster on getting heat. Thus, this method is not suitable for the producing fat lime on the commercial scale. So you can understand here, this method may be only used for the flame burning method. Only can be used for the small quantity of fat lime. And in old time, these types of method was using to obtaining the fat lime by the stones. Now, most of the commercial lime is manufactured by the burning limestone in clean, and they are permanent structure. Clean used for manufacturing lime are great variety and different designs. So, clean can be used for the manufacturing of a good types of lime. In the principle, however, they are either batch type, intermediate clean, continuous clean. In the first type clean, however, clean had to be cooled every time after burning batch limestone. The continuous type, however, are kept in the operation all the line unless they are required to stop for the repair. Further, a kiln may be mixed types or separate type design. Mixed feed, and these are the types of kiln as you can see here, which is used for the manufacturing of a fat line. Now come on the continuous clean. The essential feature of continuous lime clean is that while it is charged regularly from the one end with the raw material, and the end product is taken out regularly from the other end. As such, there is no need of coal decline every time after burning a batch of limestone. Naturally, its rate of production of lime is higher than other types of tin. Continuous clean are various types such as soft clean, rotary clean, circular clean, etc. Of these, soft clean are most popular. They are made in different designs, shapes, and sizes. And there is also some types of clean which is not, you do not need to know about all the types of clean. Basically, clean is used for the preparation of a line. Now we will see at the image of a mixed feed clean. As you can see here, that is your hooper, and this is your clean wall fuel layer. As you can see here, this is your P hole, and this is your rake holes, and grating is also here, and draw it where you have to put your line. Now we will see the manufacturing of fat lime by the clean burning. Alternate layer of limestones and fuel is placed on, then ignited through the burn hole. Main calcination reaction takes place in the central burning zone of a clean. At uppermost zone, charge is heated up with the help of quick calcination as it slides down. The clean is first loaded with the calculated amount of fuel and limestone in alternate layer. It is then ignited through the burn hole. Main calcination reaction takes place in the central burning zone of clean. In the uppermost zone, the charge is mostly heated up. This helps in quick calcination as they slide down after the some time. And these are the function of a clean burning. As you can see here, first you have to put your fuel also by the calculation of the limestone, and then you have to ignite it. And this is the image of a continuous flare type separated feed clean. As you can see here, on the upper top there will be roof, and this is your limestone where you have to put the limestone. That is your fuel shaft, and this is your refractory lining, and this is your clean wall, and this is your firebox, and this will be your foundation. Now we will see the hydraulic lime is a clay content is ranging from 10 to 30% for the manufacturing of these types of lime. The process depends upon the types of raw material available. First one is a natural hydraulic lime. This is manufactured from a single raw material and impure limestone rich in clay known as canker and occur in the nature either in the form of blocks or making lower part of the ground at many places. Canker contains 10 to 40% clay and 60 to 80% calcium carbonate. Calcination of canker is done in the clam or in plane in similar manner for the fat line. In case of canker, temperature is raised to the higher degree because of the presence of enough clay in it, then cooled and packed. As you can see here, this is the image of manufacturing of a hydraulic lime. This is your completely manufactured hydraulic lime, which we can take in the use of binding. Artificial hydraulic lime in these types of lime, two source material are required: lime, stone rock, and clay. Limestone should be free from impurities, and clay should be not contain any free silica, oxide of iron, sulfur alkalis. There are two variations of calcination for the manufacturing of artificial lime, depending upon the quality of limestone. Calcination is depend on the quality of limestone. First one is you can see limestone is the soft type, and second one is limestone in the hard type. Now you can see the image of artificial hydraulic lime, which we can also take in the use of binding material. Now we will see very important point: what is the properties of lime, and how impart a binding property in the mortar. Following are the more important properties that are determined by the quantity of lime as a building material. Physical state: lime as obtained from the clean is generally in the shape of solid lumps in termed as the lumps lime, as you can see here. Lime is crushed often by the powder required by the fineness is known as pulverized lime. As you can see, this is your lumps lime and this is your pulverized lime, and only this lime can be used in the making of mortar. Slagging of lime or hydration, the process of chemical combination of lime with the defined quantity of water so that end of product is hydrated oxide. The above reaction is attained by the following process. As you can see, this is your reaction, and this is the obtained by the evolution, expansion, and development of this lime. And this is your image of slacking of lime or hydration. As you can see here, when we add water with the lime, we will get this types of paste, and these types of paste we can take in the use of binding work. And this is the method of slaking. This is not very important point. And now we will see the tank slaking, making of lime putty. Lime putty is also very used for the foresealing of a slab. Generally we take in the foresealing of a slab. Now we will see the method of slaking. Here, what is the precautions? As you can see, only lime should be added to the water, not water to lime. Keep water stirring and hoeing for some time more, even after the boiling and hissing sound are over in the tank. Lime putty should be taken out as soon as become mature in the tank. It should be not allowed to stiffen and harden before to use. Means if it will be hardened, the properties of binding will be finished in this lime putty. So we need to do we need to take in the work lime putty before it going in the hardening stage. Now this is the method of flaking, and now we will see flaking of a hydraulic lime. Slaking of hydraulic lime, it is done by the following three methods. First one is platform slaking, slaking under pressure, slaking by the hydrator. And the basic difference in the slaking of fat lime and hydraulic lime lies in the fact that later is generally slow slaking and require less water as compared to fat lime. Now we will see again what is the properties of lime plasticity. First one is the plasticity. Plasticity is a very important property in lime because the plasticity of lime will be not good, means you cannot take in the use of binding. So plasticity, it is defined as the ability of lime to spread evenly during the application. It is observed that lime contains some magnesium oxide, more plastic, spread smoothly and easily in the combination and comparison to lime rich in the calcium oxide. Lime rich in calcium oxide, pure lime fat, hard to work, sticky and stiff quickly. Sand carrying capacity. When lime is used in mortar or plaster, sand has to be mixed with the due to the following reason to control the shrinkage of lime on setting to prepare a properly plastic mix of a desired strength. Lime mixed with the defined quantity of sand is known as sand carrying capacity of a lime. Calcium lime are said to have good sand carrying capacity than the magnesium lime. So we can take in the use of calcium lime for the binding, and it is the strength of these lime is much better than magnesium lime. And now you can see this is your plasticity, means plasticity by which plasticity is is that property which provide the binding strength in the lime. Now we will see here setting. What is the setting property of a lime? The setting of a fat lime is free state or in a mortar is essentially a chemical process which involves the following reaction: dehydration and carbonation. Two processes given here. First one is loss of water from the hydrated lime by the evaporation. As you can see here, chemical formula CaCOH2 it will be equal to CO plus H2O. And in carbonation, combining the atmospheric carbon oxide into the lime, forming once again the original material, the limestone CaO plus CO2. It will become CaCO3. The net result of setting is that it is used again to convert into hard substance calcium carbonate into the carbonated act as a binding material when used as the mortar. And the setting of hydraulic lime is a complex process. This is due to the fact that hydraulic lime contains beside oxide of calcium and magnesium, silicates and aluminates of calcium, and some oxide of iron. During their setting, these compounds get further hydrated and form the crystalline structure. Hydrated fat lime sets slowly compared to pure fat lime. The rate of setting of hydrated lime can be increased by the drying air and charging with the CO2. And shrinkage takes place in the lime on setting, which can be overcome by the mixing of sand and surkhi. And handling and storage of lime, this is also a very important point, because if you will not store your lime properly, it may be came when it will came in the contact of air more, you can say when it will came in the contact of moisture air, then this can be create the problem. Handling and storing of lime is the lime, as we know, lime is the raw from require careful handling to avoid accident and losses. Quick lime should be protected from the water as it will start getting hydrated with the evolution of the heat can be cause the burn injuries of very serious nature. If it is stored in wooden barrels, it comes in the contact with the water. So much heat may be involved in the burn of barrels. Storehouse or wagon truck in which the being the transported. Fat lime must be protected from the direct contact with the atmospheric moisture and the carbon dioxide, which starts setting and get converted to useless hard material having no binding property. It is therefore required to convert the lime into lime putty as soon as possible and stored into the compacted heat covered with the thick layer of lime dust which saves the attack of the moist air. Hydraulic lime safer in transported. Hydraulic lime is quick lime is more dangerous actually. When it will came in the water, it will be hydrated and it will also produce a lot of heat which will be cause of burning and very serious accident case. So hydrogen lime is safer in transport and can be stored in longer period as the compared of fat lime, because when it will came in the contact of water, this will be not produce heat because already there is water in the hydraulic lime. And this is the process of handling and storage of a lime. As you can see here, handling and storage of lime, there is precautions to handle lime. Workers handling lime must be asked to use the goggles and all other safety things which need to wear to the worker. Through the bath should be taken after working the lime. Actually, if it will came in the contact of ice, it may be uh, it may be uh, it may be cause very serious issue. So that's why you need to take the bath after the working with the lime. If any flammable material should be never be kept near to heap or bag of lime where lime is being hydrated to be avoided in accident fire. Now we will see the use of lime. Lime is very useful material for the find extensive application in the building construction industry and agriculture. As a construction material, lime was used as a main binding material in all type of construction till the 19th century. As I told you earlier, lime we are taking the use of lime in the old days. As you can see here, till the 19th century, it was a main building binding material for the all types of construction. Even now, lime can be compete with the Portland cement in many types of construction. As a mortar, lime mortar mixed with the sand and surkey as a plaster, as a whitewash which gives the sparkling white finish. at very low cost. As you can see, the old structure that is washed by the old government building, you will see that is washed, whitewashed by the lime, and the cost of that whitewash is very low. As the lime concrete similar to lime cement concrete made by the mixing lime, sand, and co-segregate in proper proportion. As sand lime bricks, which are quite popular in the many centuries countries. Now you can see the lime. This is your lime mortar, which is which can be used for the construction of slab, and this is your whitewash, which is done by the lime. And this is your also lime mortar, which is used for the plastering work. And this is your use of lime. And here you can see the summary to use of limestone. Can be used for the building and road, and this may be used for the preparation of these types of glasses and carbonated. And this is also this is also very eco-friendly material. And in the construction of lime load, the lumps limestone, powdered limestone, quicklime, and cement, these are available in the form of the limestones. And as the industrial material, in industries, lime find use as a flux in the metallurgy industry and factory means in agriculture this can be also used. And you can see there is using of lime. This is the use of lime. Now we will see the comparatively study of fat lime and hydraulic lime. Now you will see the properties. First, we will see the properties of fat lime and hydraulic lime. Color white color will be here in the fat lime. In hydraulic lime, that will be grayish white. And there is composition of CaO with the subordinate amount of clay, and this is the CaO with the 10 to 30% of clay. And these are the some strength. Not every strong in the mortar, so may not be used where the high strength binder is required. Quite strong mortar so can be used in the foundation and wall. In the place of Portland cement means hydraulic lime may be the alternate of cement also. Whitewashing, plastering, making mortar used as a flux in the industry, and the for the soil improvement it can be used for the making of mortar in load bearing construction for the underground and overground superstructure. You can see here setting involves absorption of carbon dioxide from the atmosphere resulting in calcium carbonate. It can not sit under the water as does not have property of hydrolyticity. Now these are the tests which we done in the lime. As you can see here, building lime is required to satisfy the number of tests before it's approved for the use of construction work. First one is chemical composition, and second one is fineness. Fineness, what is the fineness? To determine the finest grain size, CO analysis should be done of lime, and residue is weighed after the test and should be not exceed the specified limits. And soundness should be also checked for the limestone like a cement. It is tested with the help of Leach-Atelier apparatus. As we all know, Leach-Atelier apparatus can be used for the soundness test. We also use Leach-Atelier apparatus for the soundness test of a cement. Lime is mixed with the sand and water and field mold for the operator. The distance between the indicator points is noted, and after 1 hour, place the steam boiler for the 3 hour. So these tests should be done of a lime before taking the use. As you can see, this is your Leach-Atelier appraise test, which is used for the soundness test. And setting time we can use the wicket apparatus, and as you can see here, that is your wicket apparatus that is used for this final setting time and initial setting time. And strength, we can also use the compressive strength and transverse strength of a line. Average of 12 specimen tested on the standard testing machine on specimen taken after 14 days. So you can see this is your test and specification for line, which is given in IS 712 1973, and this is the graph of your test. Now we will come on the MCQ, which is very important today. And first question is there: in medium strength concrete, the water cement ratio should be not less than. There is four option is given: 0.25, 0.35, 0.4, and 0.45. And right answer will be here C. And it will be your zero point 0.4, means the medium strength of concrete and water cement ratio should be not less than zero point 0.4. If you will use less water quantity in the concrete, then your concrete can be not mixed easily. That's why we need to keep the minimum water cement ratio is zero point 0.4. Now we will see the percentage of gypsum added in the clinker during the manufacturing process is. Here right answer will be, as you can see, 2.5 to 3.5. This is your percentage of gypsum which we use in the clinker. Third question is that a sample of cement is said to be sound when it does not contain free lime. And this is a question which is related to lime. As you can see, the sample of cement is said to be sound when it does not contain free lime, silica, iron oxide, and alumina. Here right answer will be A, lime will be right answer. As per ISO specification, the maximum final setting time of ordinary Portland cement should be, what should be the maximum final setting time for the ordinary Portland cement, which is given here. 30 minutes, 1 hour, 6 hour, and 10 hours. And right answer will be 10 hours. And sometimes in these types of question, six 600 minutes is also given, means it is also equal to 10 hours. So you do not need to be confused. If suppose there will be 600 minutes, it means it is 10 hours, it is not 6 hours. Terpene is the natural material obtained by the oak trees, pine trees, mines, and any of the other, not any of the above. And right answer will be here, pine trees. There is a pine tree from where we took the terpene. Lime mortar is generally made up of. As you can see, lime mortar is generally made up of quick lime, fat lime, hydraulic lime, and white lime. Here, right answer will be hydraulic lime. As I told you earlier, hydraulic lime we can take in the use of plastering. So lime mortar is generally we use for the plastering work. That's why here we use hydraulic lime. Come on, the seventh question. Commonly used base for the paint is iron oxide, red lead, titanium white, and any of the above. Here right answer will be D, any of the above. Loss of ignition in Portland cement site will not shall not be more than. Here is option given 4%, 5%, 3%, 6%. Here right answer will be 4%. The segregation is due to, this is also very important question, lack of sufficient quantity of finest aggregate dropping concrete from the greater height over vibration, all of the above. Right answer here will be all of the above. Come on, the last question, which is low heat cement contains lower percentage of which of the following: C3A, C3S, and C2A. None of these. Here C3M is tricalcium aluminate, tricalcium silicate, dicalcium silicate, and last option is none of these. Here right answer will be A. Now come on the Now come on the reference. These two books are as a reference, and this is a very important book. If you will read this book, you will get a better idea about the limestones and lime as a binding material. Thank you for watching this video.